Welcome back, everybody. Today we're just going to have a brief conversation about number sets. Now, they're called number systems sometimes, but really they're a number set. Sets are a really important element in discussion in math. So I have taken this picture and I've made different colors to it. Now, I know that you've had this conversation many times before, but hopefully this time, this is where everything that sticks and you can clearly define what numbers belong to what sets. So my first bit of conversation is going to deal with the natural numbers. Now, what's so natural about the natural numbers? As I once heard said, well, there's nothing natural about them. But really, I want you to consider the natural numbers and all number sets are basically historical sort of ways that we look at it. The earliest numbers are the number sets, the natural numbers. I would call these the counting numbers. How do we count? 1, 2, 3, 4, and so on. Some people call these the positive integers. Now, if we go along history, we go maybe a little bit more sophisticated, and actually this has been, that number right there, 0, has caused all sorts of troubles throughout history. But anyways, what is the whole number set? The whole number set is really 0, 1, 2, 3, 4. In other words, it's the natural number set with 0 included. But we could also call it the non-negative integers, right? 0 is not negative, and all positive integers. Well, what is an integer? Well, an integer is defined with the stylized z. And most people would define an integer as positive and negative whole numbers. Now, don't forget to include 0 in there. Now, integers are kind of nice to deal with. Now, if you notice, integers are symmetric about 0. There is the exact same negative numbers as positive numbers, and they're symmetric about 0. So that's a nice way that we can exploit adding integer values and stuff like that, is look at the symmetry. All right, so we have integers. Now I'm going to go on to, we did the green, so whole or natural numbers. And then whole numbers actually include natural numbers, and then they add the 0. That's why whole is a little bit bigger. Now, integers are actually bigger than whole numbers, so all whole numbers are integers, right? Because they're contained in the integer set. And then we get on to a little bit bigger set, and it's called rationals. So rationals are defined or denoted with stylized Q. And what are they? Well, a rational number is any number that can be written in the form a over b, where a, b are integer numbers and b can't be equal to 0. Now, that might seem really complicated, but really they are any number that can be written as a fraction. Right? Now, keep in mind the conventions of fractions. So both a and b have to be integer values. Your denominator, b, can't be a negative number because that's the wrong way to write that. So anything that can be written as a negative number is an integer. This includes terminating decimals and includes infinitely repeating decimals, right? So really kind of a nice number set. So these are rationals because we can write them as a ratio. Now, what's an irrational number? Well, irrational is actually the opposite of rational, and we denote it with Q hat. And really, what is an irrational number? Is that anything that cannot be written as a fraction. Ooh. Sorry. As a fraction. So I'm just going to maybe give you some examples. A rational number is 1 over 3. It might even be 7 over 3, or 17 over 3, or 17 over 13. The numerator and denominator are both integers, negative 17 over 13 still. Now here, 0.7 repeating is also a rational number. It's a repeating decimal. In fact, that can be written as 9 or 7 over 9. So anything that can be written as a fraction is a rational number. Anything that cannot be written as a fraction is an irrational number. So I'm thinking, what is an irrational number then? Now let's talk about some examples. I think probably the most relevant example would be the square roots of numbers that you can't take. So the square root of 2, square root of 3, square root of 5. You actually don't know the true value of these numbers. When you put them in your calculator, they produce an extremely long decimal place. If you're actually to write out all of the decimals, there would be no pattern in the decimals, so it would be impossible to make a fraction out of it. As soon as there is a pattern, you could make a fraction out of it. Also, now you've dealt with irrational numbers, pi, also Euler's number E. Now you may not be familiar with that, kind of important. Now, largely real numbers. Real numbers might be the most well understood, and they're just basically any number that we have encountered. They are rationals plus irrational numbers. So that's real number sets, and they are defined by a stylized R.